All right. So today we're going to be revisiting question 4, uh, focusing on B and C. So we'll begin quickly doing A first because it's going to be required. Let's first expand the brackets so we can differentiate it easier. Okay. So if y is equal to this, then dy dx is equal to 2x minus 1. Alrighty. For simplicity, we're going to call f of x y and f dash of x dy dx. This is so we can plug in an x value easier. So instead of saying what is y at x equal 1, we just can say f of 1. So just to clarify, f of x is equal to x squared minus x minus 6. F dash of x is equal to dy dx, which is 2x minus 1. Now, before we get into the B, let's start off with the formulas for tangent at, we'll call it AB. So this could be we'll call it g of x for now. So g of x at AB, where AB could be like 2 and 5. In this case, it's 1 and negative 6. But we'll use the letters for simplicity. Basically, it's going to be y minus b is equal to f dash of a multiplied by x minus a. So if, for instance, f dash of x was equal to 2x and AB was the same as 1 and 2, the tangent would be y minus 2 is equal to, now we need f dash of a, and in this case our a is 1. So f dash of 1 is equal to 2 times 1 equals 2. And then again our a is 1. So quickly expand it out. Y is equal to 2x plus 2, and that is our tangent. Now our normal is very, very similar. It's the exact same thing except negative 1 on top. So if we were to plug it back in, we know this, so it would be y minus 2 is equal to minus 1 on 2 times x minus 1 minus 1 half x plus 1 half. Y is equal to minus 1 half x plus 2.5. So that's just the key distinction, is the negative reciprocal. So this is normal, and this is the tangent. And this is for f of x, or for g of x. Oh, sorry. Replace all the f's with g's, but you kind of get the drift. So in this question, they want us to find the equation of the normal to the parabola at the point 1 minus 6. So all we need is the coordinates and the derivative and the derivative at the specific point. So we have the points here. And now we need to find f dash of 1, basically. And remembering that f dash of x was our dy dx from before. So let's write this all out, just so we have it in front of us. It's one of the best ways to set out work is to write everything you know, and things will come easier just by looking at it. So let's get the formula. It would be y minus, in this case, minus 6. 1 on f dash of 1, negative as well, this is important, times x minus 1. If you aren't given this, so they said at x equals 1, you would get this by subbing in f of 1. But they've given us coordinate. Now, let's find f. We know everything here. Only thing we are unsure of is f dash of 1. So if f dash of x is equal to 2x minus 1, f dash of 1 is equal to 2 minus 1 equals 1. Let's sub that in. So y is 10 to the plus 6 equals minus 1 on 1 times x minus 1. Simplifying it out, y plus 6 equals negative x plus 1. And then y equals, let's move the 6 over, 1 minus 6, which is minus 5. And there is your equation to the parabola. So let's label this equation to parabola. Equation of normal. And you could say equation of normal to the parabola y equals x minus 3, x plus 2 at the point 1, negative 6. But this normally is okay, unless you get asked for multiple normals at different points. Now C, find the coordinates of the point P where this normal, so when they mean this normal, they're linking to the equation you just found. So let's highlight that. Crosses the parabola, y equals this. So we want these guys to meet again. And this makes sense because in order to be a normal, you must meet it at least once, and just so happens that it meets twice. So the point P, we don't know. The only thing we know is that the normal touches the parabola twice. We are told this basically, but a question could be, does this normal cross the parabola more than once? And you'd have to figure it out. But in this case, all you'd want to do is make the normal equal the parabola again. And by the parabola, I mean the equation. And by the normal, I mean the equation we found before. So let's start by finding the x value of which the y's are equal. So when does the y normal, and this is minus x minus 5, equal y of parabola? This was our f of x before. Because that is what we're asking, we join them together. Cool. So let's move everything over. Now we plus this x, and then we plus this 5. We end up with x squared minus 1. Now this is just a equation to solve. Move the 1 over, that means x is equal to plus minus 1. Because we take the square root of 1, and the square root of 1 is just 1. Now notice how the plus minus is outside the surd rather than this. Because this makes sense, because 1 times 1 is 1, and -1 times -1 is 1, meaning that 1, there are two ways to take the square root of 1. So we've said again, because it's already touched once, at the point 1 and -6. So we know, oh, sorry, we know that it hits at +1. Well, we'll just call it 1 now. 1 when y equals -6. So we want to find -1 and what this y coordinate is. The way we do that is sub it back into either one of the equations, because we want to find out the other y. So we found that y normal equals the y of the parabola when x equals +/-1. So they are identical at x equals 1 or x equals -1, meaning you can use either or to sub back in. I would say sub -1 into the normal, because there's less variables you have to deal with compared to a square. So let's do that. So yn at x equals -1, you end up with -1 minus 5 equals 1 minus 5 equals -4. So that means coordinate P occurs at -1 and -4. We know it's not 1 and 6. Was it -6? Because this was already told and they wanted us to find the second point, second unknown point is found. Awesome. So let me know if this was unclear or if there are any other steps. I'm also happy to go over the formula again. I might as well go through it now. But let's say you're given, you want to find the normal / tangent to f of x at a. So if they didn't give you coordinate, they only gave you the x value. The way you do it is y minus f of a equals f dash of a times x minus a. This is for tangent normal. Y minus f of a equals -1 on f dash of a times x minus a. See how they're very, very similar. The only key differences is the gradient here. Now, so this is an x point. What if they ask you to find it at a y point? Let me run you through it. At 2x f of x equals 6, or f of x equals b. And this, they might use y. So for example, at y equals 6. The way we do this is we can't. There is no formula. Only way is you have to resolve it for x. You have to find this point. So that way you would go f of x is equal to 6 and solve. So for example, if f of x is equal to 2x, we'll call it x squared. You'd have to solve x squared equals 6, x equals ±√6, and there'd be two different tangents and two different normals. It would be, so we'll start with the tangents. Y minus f of √6 equals 1 f dash of, f dash of √6 times x minus √6. And then you have to repeat this process again. This one is slightly more challenging because there's two solutions, and this is just a odd specific case. And then normal would just be a -1 on top of it. And that's about it. So let me know if there are any further questions, and I'm gonna make another video to help out. All right, thanks guys.